So we talked about 3 different types of nonlinear models yesterday. This says use the data to create 2 of the most reasonable models. Explain which one is more appropriate and why. Then, whatever the most appropriate model is, use it to answer the questions at the bottom. 0 is not used in logarithmic because thou shalt not log of a non-positive. If logarithmic is one of the 2 reasonable models for this data, then you will have to somehow alter your x values. Reflexes of an inbred Jedi. When you are finished, a couple of things to get ahead of the game. Make sure that you have your Chapter 3 packet ready to turn in. Your name is on it. If you have to turn in your notebook or anything like that, it is a white day. I will attempt to get notebooks done right away. What else? Is there anyone who knows they're going to be gone on Tuesday? Sometimes people... Okay. Stop by this afternoon to grab a Chapter 4 packet. I'll be running those off next hour. Is that volunteers get to go, or is that only the good kids go? You said some of us.
Well, there's like a meet on Tuesday, Friday, Saturday, so trying to figure out. Yeah, they're trying to like split.
Gotcha.
So yeah, Friday. So Friday, I think I'm for sure going. Saturday, I'm still going. So she like.
Some folks still furiously typing. A little bit more time. Just do this now. Remember, it's not enough to just put your two models. Which one's more reasonable and why? Yeah. These are the viewers who hate crap, get downloadable, or ad blocker. It's the same people. I don't want to see talking head in front of my random YouTube video, so I get ad blocker.
What does it mean that says error, no sign changed? What that is?
You have to interpret this. You attempted to find thing. Calculator says thing does not exist. What does that mean?
I got it.
So basically, instead of homework, this. Do you get what we were talking about yesterday? I know you know how to press buttons. Do you get what we were talking about with those three models? Granted, yesterday was kind of a dumpster fire. I was really, really tired. Well, that's because the whole lot of you were probably up until 2 or 3 in the morning for the previous few nights because, oh, no school. Jealous. I am so jealous. Dude, I started moving snow Tuesday night at 9:30.
If I'm done with homework.
Yeah.
If I'm done with homework.
Okay. We're there? Probably don't want that screaming dinosaur in front of you. So we all know how to press the buttons. How do I get data into my calculator? Stat, edit. You dump all the stuff in, double check your numbers, double check my numbers. Make sure that I didn't. Like, Frank really doesn't like decimal points and zeros, anything on that bottom row. So like sometimes that'll turn into a 3 instead of a 30, a 45 instead of a 4.5. It looks decent. Okay. So if I'm going to determine which models are going to be the most reasonable, I should probably just look at my data on a scatter plot to determine what type of function is going to fit that shape. So I'm going to go to my stat plots, plot one on, make sure it's your correct list, monkey with the visuals of it if you want. I will zoom to my, you know what, instead of zoom to my stats, well, we'll do that to start with. Zoom stat, and I see, all right. So yesterday we talked about exponential, logarithmic, and logistic. Which of those is out because of how this looks? Logarithmic is out because it's curving the wrong way. Concave versus convex, right? So it's curving the wrong way. That means my two reasonable models are probably going to be exponential and logistic, just because of how it's curved. So I'll go find those two. I'll find stat, calculate. We'll go contestant 1, exponential regression. I'll put it into Y1. Okay, we all know how to press the buttons. Don't need to slow down for that. The only thing that's going to slow us down is Frank. God, I'm terrified for how long the logistic is going to take. Okay, so you write down your model, and we say contestant 1. Y is approximately 1.71 times 1.042 to the x. So there's a model. I'll go stat, calculate, logistic, and then in typical Midwest fashion, while this is taking its sweet time, we will kill that time by, I don't know, talking about the weather or something. Okay, that's going to take a while. So while that's doing the thing, remember you got to know for Tuesday. You got to know SOHCAHTOA, you got to know your special right triangles. If there's a chance you're going to be gone on Tuesday, stop back after second hour. I will have the chapter 4 packets. I'll let you know they're thick with a couple C's. Like it's going to be, we're going to be in that chapter for like solid 3 weeks or so. It's a big one. But then after that, chapters 6, 7, and 10 are each like 6 days. Yeah. Well, think about it. Quarter 4 midterm is next Friday. Right? Fourth quarter midterm, April 14th. I think they put it on the wrong week though, because it's supposed to be 4.5 weeks. That's 5.5. Oh, I think they have it a week earlier than normal because it's the midterm for our seniors. That's why. Okay. All right. What was color 2 on here all the time? Blue? Right? Yeah, so blue. Okay, so Y2 is approximately 55.861 over 1 plus 50.24 e to the negative 0.064 x. So, how'd our models turn out? Okay, great. I know how to press buttons. Now we answer the questions. Okay, the questions are 2 reasonable models, check. 1 point, 1 point. Use, okay, now which one's going to be more appropriate? So let's talk about the number of ads is going to be our X, the percent of viewers is going to be Y. I said we were going to start with Zoom stat. I want to change my window to model a reasonable set of data. If I'm changing my window, and X is the number of ads that you can see on YouTube. Everyone has like Vietnam flashbacks, right? You can have a lot. So I'll go out to at least 100, right? Or wait, what was my data? Went out to 90. Let's go to 200. Let's change that just so I don't have a blurry line at the bottom. Okay, why was percent of viewers who then say, nah, block this? What's a reasonable range for this? 0 to 100. It's percent of viewers, right? I'm going to go 0 to 100. I'll go by tens. Now let's look at the graph. So there's my data. There's my exponential model. Not the greatest. And come on, Frank.
Come on, Frank.
You can do it. You can do it.
Come on, Frank. There you go, Frank. Wow.
Ooh. That was perfect. And it has that limit that we were talking about with logistic. So, which of these makes more sense? Okay, that was the big thing we talked about yesterday. Like, yeah, I can press buttons, but every time that we have had an exponential model in the past, it should probably have been a logistic model because things can't continue exponentially forever. Particularly, I can't have enough ads that eventually make 300% of viewers do a thing. It doesn't make sense. People are lazy. There's a natural limit to a thing. For example, okay, there's political ads. Think about voting. There's a lot of very contentious issues right now, and yet you're still going to see voter turnout rates at like 60%. You're still going to see like 40, 30% of people who just never go. Now, a good part of that is voter suppression laws and that kind of stuff, but you're going to have a percent that just never do it. Okay, think about coupons that give you free money when you go check out at the grocery store. How many people don't do that? You go to Safeway. Okay, if I just put in my phone number, I get the member discount, right? But they also have the things that are like digital coupon with their app. You know how many people just never do that? There is going to be a natural limit to people who are willing to do a thing. Okay? So, I have my two models. My more reasonable one is logistic, and I'm just going to say logistic. I'm going to say it's logistic because percent can't go past 100. Like, that's simple. The percent of people who do a thing can't go past 100, or it can't increase infinitely. Something to say this can't go up forever. Okay? Y cannot go to infinity, or cannot go past 100. You have to have something in terms of words that say, I will choose logistic because it makes more sense in the context. Then, using that model, what? I don't know, it got small. Whatever, we can still read it. Use your chosen model to predict the percent of disaffected viewers after 125 ads. So I'm going to either go to my table or I'm going to plug in an X value, whatever it is, trace. I don't want to be on my stat plot. I don't want to be on my exponential. I would like to be on my logistic. I will go to 125 ads, bloop, and say about 54.9, or if you just said about 55% of people. Okay? So we'll say, and then, Frank? Frank's freaking me out. After how many ads will 60% of people download an ad blocker? If you listened to anything about the logistic one yesterday, never. because my natural limit to that function is at 55.861%. You had a model, you had a model. You said which one was reasonable, you answered the question, you answered the question.
Yay.
Okay. All right. On to the review. Again, we want to give you plenty of time. In the last 6 days, we started with definitions of logs and logs by graphing. Graph the function, identify domain, range, intercepts, continuity, intervals, increase, decrease, all the stuff. Analyze. So if I was going to go by transformations, you don't have to write this part, but I see a vertical translation up 1. I see a vertical compression of 1/2. I see a vertical reflection. And I see that I'm going to be using powers of 3. I'm going to use those to graph. You can just graph by points if you want. Okay? So, my asymptote, stop that, is still at 0. We didn't have a horizontal translation. I'm going to have that initial point that is normally on the x-axis because anything to the 0 power is 1. So the log any base of 1 is 0. Yep. So normally we have this, but I'm going to move it up 1 because of my vertical translation. Normally, after that, if I'm talking log base 3, I would go from the point 0, 1. I would go up 1 and over 3. These aren't the actual points. I would go up 2 and over 9. I would go down 1 and over a third, down 1 and over a ninth, and so on. That's what it would be, because there's a vertical reflection. This would go here, this would go here, this would go here. Okay? That's my vertical asymptote for logs. Yeah?
Wait, are you graphing from the point or from the asymptote?
Always from the asymptote. Just like exponential graphs are always from your horizontal asymptote, logarithmic graphs are always from your vertical asymptote. Okay? And this is something that some of us were goofing when we did these graphs originally, like a week and a half ago. This is a vertical compression by 1/2. The horizontal distance out to those powers of 3 doesn't change. It's the vertical spacing that changes. So instead of going down 1 and power of 3, I'm going to go down 1/2 and power of 3. Instead of going down 2 and over 9, I'm going to go down 1 and over 9. And then up 1/2 and over a third. Up 1 and over a ninth. Okay? So the points that I should see, if I'm just graphing by points in my calculator, I'm going to have what? 1, 1, 3, 1/2, and 9, 0. Remember that the calculator gets kind of dumb with these. All it's going to show you is this. You got to be smarter. You got to know that this curls along a vertical asymptote. The calculator is just saying I'm not allowed to show you that because it's too close. So you got to be smarter. That's another reason that I put my vertical asymptote on my graph so that I remember to not cross that line. Okay, now all the stuff. Domain. From 0 to infinity, like most logs, unless I have horizontal translation. My range is still all real numbers. My intercepts, we never hit the y-axis, but my x-intercept is nicely over there at 9 powers of 3. Continuity, it's continuous from 0 to infinity. It is decreasing the entire time and never increasing. End behavior, do we remember how to write these? The limit of my function. Ah, Jesus. Frank's like cross-eyed right now. It's driving me nuts. Come on, Frank. Please don't crap out on me during a review. The limit of my function as x approaches, the limit of my function as x approaches, we know as we go all the way to the right, this is heading off to negative infinity. That's easy. Do you remember the left end behavior of this? As I approach 0 from the positive side, it goes to positive infinity. And the easiest way to remember those end behaviors is just to go to the ends of your graph or the ends of the domain and write it like a coordinate. Treat this like 0, infinity, and treat this like infinity, negative infinity. And then that just straight up tells you what, as x approaches this, y's go here. Okay? So we started with the graphs and analysis. Should be easy peasy after chapters 1 and 2. Then we talked about definition of logs. Notice there's 5 things here. Hint, hint, 5 points. And it does say show work to display the properties, meaning I know that you can just jam all of this in a calculator. That means no one should get them wrong, right? Because you can check your answer. But I would like you to show me you understand the property that got you there. And it can be something as simple as log base 7 of 7 cancels. Okay? Like if I just see that, I know that you know. Okay? E to the ln of negative 5. It ain't negative 5. What is the ln of negative 5? Okay. Log base 25 of 1/125th. Going to end up with a rational number. Here you would probably want to use my definition. That 25 to what is 1 over 125? And then rewrite that. What base do they share? I hear like 7 people whispering 5. Yes. And 5, how do I get 5 downstairs? Negative. And then our one-to-one property says 5 to a thing equals 5 to a thing. That is negative 3 halves. ln of e to the ln of e to the 0. That cancels, 0. Whee! And log base 6 of 216. do we all know are squares through 20, cubes through 10, fourths through 5. That is 6 to the third. Okay. And if you just did something like this, like you understand 6 to the third makes this number. Okay, so when I say show work, it can just be I scratched out these things. Okay? So we have all the various properties of logs, like by definition. Expanding and condensing. When we went through the expanding thing, I had told you that come test day, someone's going to do it. Someone in here is going to be like, oh, no, I know this. This is super easy. It's going to be the ln of 9 plus the ln of x to the third. 3 comes out front. It's going to be the ln of y to the negative fourth. Negative 4 comes out front. They're going to move on to the next one, and they're going to get their test back and face palm. Why? No, it's not. There's no parentheses there. ln of 9 is the ln of 3 squared. The very first thing that I would do on the expand problem is if you see a coefficient in there, if you see any numbers, break them up by prime factors first. Go prime factor tree if you have to. If you're fortunate, you might have a TI-36 on hand where you can just hit math 4 and it does prime factorization for you. So, condensing on the other hand, I'm going to have log of, this guy comes up. Be careful, what does it apply to? Both of them. And this guy comes up. So x to the 1/3. What is that? Cube root of x. And it happens to be positive, so cube root of x goes upstairs. Because this is negative, that means it'll head downstairs. Also, if I just rearrange this into 1/3 log base 9 of x minus 5. Yes. How many of us, someone's going to do it on their test. Someone's going to forget that base 9. Don't get got by the little stuff like that. Okay? If you would just rearrange this to say log x minus 5 log, if you had just rearranged it, you would have seen, okay, I'm going to have a division problem, a quotient. So because that's a negative exponent, I'll throw it downstairs. I'll make sure to apply the negative 5 to both of them, so that's 2 to the negative 5th, or 32 on denominator. X to the negative 5th, or x to the 5th on the denominator. So I don't have to rationalize here because my radical is on the numerator. 2 to the 5th. Yeah?
On the expand one, when you bring the 4 down, it doesn't go, does it go on the bottom then? Because then it's minus 4 log.
If I was condensing them back together. Okay. Because that was the ln of 9. Right. What was it? X to the something, y to the negative 4. I could also write that as 9x to the whatever it was over y to the 4th, which is why when I expanded it, it was minus 4, Lenny. Yep. Yep. There was a radical in here. There's x's inside radical and outside radical. Do I need absolute values anywhere? Okay. Careful. If for example, I ended up with an even radical on my denominator and I needed to rationalize, I might need to throw that variable that comes out of it when I rationalize into absolute value town. Yes. I don't think I had that on any form of the test because that was a higher order thing. But I'm not sure because I've been doing this for, what, 7, 8 years now, and I've got a lot of forms of the friggin' test. Backside is all equation, 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 equation. We spent a lot of time on these because this is where I think most of our Algebra 2 experience kind of left off or didn't get to this or didn't expand upon it. So we've got a bunch of it. Round 1 is I got to log both sides and work with ugly. Okay. So we'll start with I'll log u and I'll log u, which means these come out front as coefficients. Be careful. Over the years, I've seen a couple of kids just try to bring exponents out as coefficients without a logarithm there. Just, no, that's a property of logs. You can't just do that to exponents, okay? Write out that is now 2x minus 5 times log 3. That is now 3 minus 4x times log 6. I'm going to distribute, and as we found, it gets kind of squirrely when you're writing 2x times log of 3. And I think we were okay with starting to write it as just a coefficient of x. It's that many x's. Okay, I can write it like that. I can write it like that. I can write it like this. That last one is kind of dangerous because we might think it's 3x as an object of the log. Okay. Over here, if I disturb it, we have minus 4 log 6 x's and 3 log 6. The goal of any equation is x's to one side, not x's to the other. So I'll add this guy over. The terms cannot combine normally, so it's just going to be a big but ugly 2 log 3 plus 4 log 6 x's. I'll add this guy to the other side. And if I've got thing times x, the way I get rid of it is by dividing, and I get my big ugly expression. X is 3 log 6 plus 5 log 3 all over 2 log 3 plus 4 log 6. Double check your instructions. Write as a simplified expression and decimal equivalent. So, as the goof troop says, get in the chopper. If I'm going to combine these logs using my properties, I want to put all those exponents up. This becomes the log of 6 to the third by 3 to the fifth, which is 216 by 243. I ain't doing it. Too tired. Log of 3 squared by 6 to the fourth, which is 9 by 1296. Still not doing it. I'm tired. So, who's got that calculator mojo? Log a big over log a big. I'm 52 mutter mutter. Okay. Or, because it is a log of a thing over a log of a thing, that's our definition of our change of base formula, you could say log base 11,664 of 52,488. And then assuming that you know how to press buttons on a calculator, you would give me a decimal approximation with it. Oh yeah, they're always tiny. What's up? 52488. Everyone was muttering, so I had to squish my 4 in there. You can tell when the confidence level is low because everyone kind of turns into a mush mouth. Okay, so there's an exponential equation. We also dealt with exponential equations that were in quadratic form. If you got a U substitution, go for it. If you don't need the U substitution, don't do it. Okay, some of us are content with 3e to the 4x plus 10e to the 2x minus a to 0 and factoring as is. The only way that you're going to get a 3 out front is with a 3 and a 1. My middle term for quadratic form determines what each of my binomials will have. And if you can rep through the factors of -8 to get the magic combination of 10 in the middle when you distribute and add, you will have a +4 minus 2. And just like when we were doing these as plain old quadratics, set this equal to 0 and solve, I'll have a e to the 2x is 2/3. 12 minus 2. I'll write the other work off to the side.
I'm just confused because I haven't done this. What if we did the 3 times the 8?
I'll do that off to the side. I just need to write this. Because if we can't do that, then over here, we would have to identify what my middle term is and say u is e to the 2x. Replace that with 3u squared plus 10u minus 8 is 0. AC method. I would go 3 times -8 is -24. Factors of -24 that add up to 10 are +12 and -2. I'd cut that in half and say these got a 3u in common, leaving u plus 4. These have a -2 in common, leaving a u plus 4. Getting u plus 4 and 3u minus 2. Setting that equal to 0, I would say u is -4 and u is 2/3, and then I would remember, oh wait, it ain't u, it's e to the 2x. Okay, so if you got to do the side work, do the side work. That's why I try to leave a lot of room on the quizzes. Now, you get there. Are we okay to continue from that point? How do I get that 2x out of exponent land? I got to log them. And when I log, I'm going to use natural log because they're base e's. If I ln this and I ln this, and ln this and ln this, this guy is just a big fat no because I can't take a natural log of -4. But over here, I'll get 2x is the ln of 2/3. Divide by 2, and I can write this over 2, or I can just shove a 1/2 in front. Your choice. Okay. Yeah, because if you brought that 1/2 up as an exponent, now you have a square root of 2/3, which is the square root of 2 over the square root of 3, so you have to rationalize it to square root of 6 over 3. No, just leave it. And then whatever your decimal is, you could just nicely jam that in with the answer button to check. Okay? So, cool. And finally, log equations. And we see some real big numbers in there. We might get a little scared. But I can only use my one-to-one property of logs if I have 1 log equal to 1 log. I don't. So I will use my product property to make it that way. Log of, I'm going to take this guy times this guy. Distribute, combine like terms, don't do like freshmen. We'll have 16 and 20 is 320x squared. I'll have a negative 32x plus 40x is plus 8x minus 4. So it looks big and scary, but then, okay, when I get rid of the logs, one-to-one property for logs, and now I see I've got a quadratic. Well, I'll put everyone on one side of the bus, and 320x squared minus 319x squared, not too shabby. 8x minus 9x, negative 4 plus 2. Solve by however you need to. In this case, I'll factor. X minus 2, x plus 1. Getting answers. X is 2 and negative 1. My original equation has logs in it. Thou shalt not log of a non-positive. I have the possibility of extraneous solutions. So right out the gate, we should see that if we plug a negative 1 in here or here, it's very bad. So that's got to go away. The 2 squared 4, it's going to be log of big equals log of big. They should be the same. Okay. So it should. All right. We got room. Spread yourselves around. Mix yourselves up. Like a solid 40 minutes this time.